Welcome to Unit 2, Refactoring, Module 1, Loops, Lesson 1, For Loops. So repetition is an important part of music. Computers can execute statements over and over again using a loop. A for loop tells the computer to execute a section of the code repeatedly, common notations in most programming languages. We can use for loops to avoid repeated lines or sections of code. This is called refactoring. Here's an example of a for loop. Let's take a look at it a little bit more closely. We have the loop counter, we have the range, and we have the loop body. Let's talk about those three. Notice this is not in the loop. So the loop body. This is the body of the loop that contains the statements that will execute repeatedly. It includes everything that is indented using the tab key directly after this colon. The loop counter creates a variable to be used as a loop counter. It keeps track of where you are in the loop. So in this case, measure is the loop counter. The range is a function that makes a list of numbers for the loop counter to count through. The keyword in checks if the loop counter value is in the specific range. Sorry, the keyword in. So in is the keyword there. Range takes two arguments, a starting point, inclusive, so it includes the number 1 in this case, and an ending point, which is exclusive, so it does not include the number 9. Range, starting number, ending number. Indentation in Python is critical. It affects how the code is executed. The statements inside the for loop body should have the same indentation level tabbed in from the first line. Python will not recognize unindented code as part of the loop. In fact, you're going to get an error sometimes if your indentation is wrong. So as soon as the indentation ends, the loop body ends. So if we go back and look at that code, this is part of the loop body because it's indented. Whereas this is not part of the loop body, it's not indented. So here's an example of code that needs to be refactored with a loop. You can see that we have a whole bunch of repeated commands here. We're going over and over and over again saying these two commands over and over with just one little change. We're only changing the number here at the end. A couple other little changes, 3, 4, 5, 6, 7, 8. It looks like it's counting up. That's a good sign that we can use a loop. So if we look at this code, what we've done is we have our counter called measure. We're in the range from 1 to 9. So we're going to start at 1 and go all the way up to 9. And then we're just going to run two fit media commands. And notice we have measure tells us where we should be starting, to measure plus a half. And then we're going to do measure plus a half to measure plus 1. So that'll go through and do the same type of iteration where we're increasing by a half each time. So instead of having to write all these commands here, we can just write these two commands for us, and it'll go through and track through that loop for us. So in our range here, the numbers that we count through are 1, 2, 3, 4, 5, 6, 7, and 8. We're not including the number 9. This is because the range function's ending number is exclusive, meaning the number is not included in the list. The start number, on the other hand, is inclusive, so the number 1 is included in the list. This for loop is saying keep looping until we count through all the numbers created by the range function. In this case, the range function we specified lets us place music up to, but not including measure 9. So how did this for loop actually work? Well, the interpreter reads and executes a script. The order of the execution is called the flow or the control flow. Normally, line by line, top to bottom. A loop is a control flow statement. We can use loops to change the control flow order. At the end of the loop body, it jumps back to the top of the loop. Let's see how this works in practice. So we can follow this image here, and we can see that we're starting at the number 1. So measure stores the value 1. Then we're going to run the first fit media command, the second fit media command. Then we're going to go back up to the 4. Now measures 2. First fit media command, second fit media command. Now up to the top again. Now measure is 3. Fit media command, fit media command. Now, go back up to the top of the loop. Measure is now 4. Fit media command, and now we stop because 5 is not included in the range. So we test that, no more numbers in our range, move on to the next statement. So we can see the last thing it does is it runs this command because this is outside the loop body. So you often want to increase or decrease a variable, and similar to how a loop counter increments on each iteration of a loop, instead of writing something like measure equals measure plus 1, which algebraically looks a little weird, we can have a shorthand to do this. So instead of saying measure is assign the value of 1 more than the current measure, that's what this really says here. The shorthand that we can use is measure plus equals 1. So we're using this operation here called plus equals, and it says to take this variable and increase it by 1. Minus equals, you should be able to guess this one, takes the variable and decreases it by 1. So plus equals and minus equals are very common in many different languages. I know it's not common in algebra, but this is not algebra class, this is computer science class. So now it's your turn. I want you to create a program that writes 100 measures. Yep, that's right. I want 100 measures using a for loop and one fit media command. That's supposed to say fit media command. You get to choose whatever sound you want and just make it go 100 measures. That's your assignment. Remember to submit the .py file and the mp3 file. I probably won't listen to all 100 measures, just to let you know. Never stop coding, and I'll see you next time.